welcome to the chain rule and integration. So just recall that if capital F prime of x is equal to lowercase f of x, then if we want to take the integral of lowercase f of x dx, one antiderivative would be capital F of x, and then we have our plus c. So if we have a derivative fact, we can write a corresponding integration fact. Right? And also, as we saw in the last video, our chain rule, we had that if we wanted to take the derivative of f of g of x, that this was equivalent to taking the derivative of f with respect to g of x, or evaluated at g of x, and then multiplying by the derivative of g evaluated at x. So let's go ahead and consider the function f of x equals 3 times cosine of 2 to the x. We're going to find the derivative and then write the corresponding integration fact. So we have f of x is equal to 3 cosine of u if we set u equal to 2 to the x. So f prime of x, we would have the derivative with respect to u of 3 cosine of u, then multiplying by du dx. So we have -3 sine of u, and then multiplying by the derivative with respect to x of 2 to the x. And this becomes -3 sine of 2 to the x, plugging back in our 2 to the x, times the natural log of 2 times 2 to the x. So this is our derivative fact. So essentially what we just found was that the derivative with respect to x of 3 cosine of 2 to the x is equal to the -3 sine of 2x times the natural log of 2 times 2 to the x. So if we want the corresponding integration fact, we're going the other way around. So what we would have is if we wanted to take the integral of -3 sine of 2 to the x times natural log of 2 times 2 to the x dx, we get back what we started with, which was 3 cosine of 2 to the x, and then plus c. And then I'm just going to use some notation. So this was, we were evaluating at u, and then this part here was du dx. And we got back out evaluated at u. So let's go ahead and do another example. Let's consider the function g of x equals the natural log of cosine of x plus 2. We'll go ahead and find the derivative and then find the corresponding integration fact. So here our u will be cosine of x plus 2. So we are looking at g of x is equal to the natural log of u. G prime of x is therefore equal to the derivative with respect to u of the natural log of u times du dx. From there, the derivative with respect to u of natural log of u is just 1 over u. And then we are multiplying by the derivative of cosine of x plus 2. So this becomes 1 over cosine of x plus 2. And then we're multiplying by negative sine of x. So we have that the derivative with respect to x of the natural log of cosine of x plus 2 is this 1 over cosine of x plus 2 times negative sine of x. So what we wind up getting then is if we wanted to take the integral of 1 over cosine of x plus 2 times negative sine of x, that whole thing times dx. This winds up simply being the natural log of cosine of x plus 2 and then plus c. In this case, I didn't use absolute value because cosine of x plus 2 is always positive. So we don't need to put in the absolute value signs. All right, let's go ahead and do one more. Oh, just a quick reminder for, again, this part here is u. This is du dx. And again, here is our u. So let's look at one more function, h of x equals e to the 2x squared minus 7x. We would set our u to be that 2x squared minus 7x. So we have h of x is equal to e to the u. Then h prime of x would be the derivative with respect to u of e to the u times du dx. And this winds up being e to the u times the derivative with respect to x of 2x squared minus 7x, or e to the 2x squared minus 7x times 4x minus 7. So if we write our corresponding integration fact, we have the integral of e to the 2x squared minus 7x times 4x minus 7 times dx winds up giving us that original e to the u, or our original function. We had the derivative, we were looking at the derivative of e to the 2x squared minus 7x. Right? So we would get back out e to the 2x squared minus 7x from our integral, and then of course plus c, since we're working with an indefinite integral. So again, here is our u, here is our du dx, and here is our u. So essentially what we're doing is we are forcing our integrals are taking a format where we have a function we know the derivative of in terms of u, and then multiplying by du dx. So in the next video, we'll get this more explicitly, sort of how this appears. But this is kind of what we're focusing on here, is we're looking for a chain rule result to then backtrack to the original from our integral.